Hello. We are going to be factorizing this huge number, 255,765,765,255. Now I'm going to show you some big tricks that help you factorize numbers and find its prime factors, because usually there's some sort of focus on, like checking out the last digit. Okay, the last digit is 5, it's divisible by 5. Maybe you add up all the digits and then you see, is it divisible by 3 or is it divisible by 9, and then you try and do it. I'm going to show you a slightly different approach. We will use those tricks, but later. We need to look at the number as a whole. So we need to be like a detective. We need to be looking at the whole scene before we try and disturb it, and we want to try and see if we can deduce some quite important fact about this number. So one of the first things to look at is patterns in the digits. All right, so we've got 255 here, and we also have 255 here. So we've got some sort of repetition. We also have 765 here and 765. So we've got some repetition, but there's also a link between 255 and 765, and it is that 765 is 3 times 255. So this is really interesting. All of them are divisible by 255. So that's an immense simplification we can make straight away. So we can rewrite this thing as 255 times by 1 billion. All right. 1 billion, and then it's going to be 3,003,001. So we've already separated this out into two significantly smaller numbers. Now this number on the right, we will come back to the 255, but this number on the right is really interesting. Now some of you may recognize these as coefficients of Pascal's triangle, and that's a really good thing if you've recognized that. But I want to show you how you can try and analyze this and split it up, even if you didn't know about Pascal's triangle. So the important thing to realize is that this is kind of like, we've got this 3003 in the middle, and it looks like it's got some repetition inside it as well. So we want to try and break it down into 1001, followed by a bunch of zeros. And then we can break it down this into 2002, followed by a bunch of zeros. And then we have a final 1001. So this is really interesting. Every single one of them now can be divided by 1001. So it's going to be 1001 times by 1 million, and then 2001. Now we can actually do the same trick again with this number. We can split this one into 1,000,000 and 1,000, and then 1,001. So now we know that this whole thing is actually 1001 times by 1001 times by 1001. It's just 1001 cubed. Now that is a massive simplification. We're going to reuse all of that. Now let me just rub that out, and we're going to put this in. So we now know that this is 255 times 1001 cubed. This is fantastic. Now all the numbers are getting significantly smaller. Now 1001 is quite an interesting number. It is possible to use one of our smaller tricks. Now the way that you check whether a number is divisible by 3 is you add up all the digits and you see if it's divisible by 3. So 1, add 0, add 0, add 1. No, that's 2, so that's not divisible by 3. There is another trick that you can always use on symmetric numbers, like palindromic numbers with even number digits. So if you add up their odd number digits, so 0 and 1, so 1 plus 0 is going to be equal to 1, and then you add up the even number digits, and that's also 1 plus 0 equals 1, and then you subtract them, and you get 0, that means that it's divisible by 11. In fact, if you get any multiple of 11, it will be divisible by 11. So now we know that this is divisible by 11. So roughly, let's just say, okay, well, what would 90 times 11 be? What would be 990? Oh, we need another 11. So it's going to be 91 times 11. And 91 times 11 is going to be 1001. You can practice this with other sort of palindromic numbers. It's a really good trick to get good at. Once you can spot it in a few places, you can spot it in lots of problems. So now we can write this as 91 times 11 cubed. Now this is great because 11 is a prime number. The first one has bitten the dust. We've got the first prime number. Now let's have a look at 91. It feels prime. Is it prime? With a bit of thought, you realize it's 7 times 13. 7 times 10 is 70. 7 times 3 is 21. And both of those are, in fact, primes. So now we can write this as 255 times 7 times 11 times 13. I'm just putting them in order there. That's awesome. So now we've been able to deal with everything in that massive number. Now we can draw attention to 255. Now you could probably just be like, okay, well, this is divisible by 5, and then you can make it simpler. But I want to show you a really, really cool trick with numbers like 255. So 255 is not a random number in this problem. 255 is in fact 256 minus 1. Now 256 is of course 2 to the 8, and 1 is 1 to the 8. This is actually a difference of 2 squares. This is a super useful technique if you can ever spot that a number is the difference of 2 squares, even if they're higher powers as well, as long as they're higher even powers. What you can do is you can do this repeated expansion, where you can do that. This is 2 to the 4 minus 1 to the 4 times 2 to the 4 plus 1 to the 4. Now this term here is also a difference of 2 squares, so you can expand it out again. So this whole thing, let's just change the order. The whole thing becomes this: 2 to the 2 plus 1 to the 2 times 2 to the 2 minus 1 to the 2. And the last one, we can do this as well, although it's a bit superfluous because it will just be 1. But let's do it anyway. This becomes 2 plus 1 times 2 minus 1. And now it's really easy to work these out. 2 minus 1, of course, is 1. 2 plus 1 is 3. 2 squared plus 1 squared is 5. And then 2 to the 4 is 16. 1 to the 4 equals 17. Now this is really great. They are all prime numbers. So we can just stick all of this back in. Let me rub all of that out. And now we have it. Okay, we got that. Let's just copy that. And we've got the prime factorization. Let's just put it in order. We don't need the 1. It's going to be 3 times 5 times 7 cubed times 11 cubed times 13 cubed times 17 cubed. So it's divisible by all of the first 6 odd prime numbers. There you go. So I hope you found this useful. There's a bunch of cool tricks in here that can be applied to other problems. If you found this helpful or interesting, please hit the like button. Let me know your thoughts in the comments below, and of course subscribe so you won't miss the next video.